Hi, in this video, we want to take a look at the major types of data that we work with when we're doing statistical analysis. Okay, so in this video, we're taking a classic statistics point of view. We're not going to be worried about things like unstructured data, structured data, videos, recordings, things like that. We're going to be keeping it pretty fundamental, foundational aspect, and we're going to work through this. So there are going to be 4 types of data that we're focusing on, and we need to understand the different types of data as we work through our project so that we choose the correct methods to visualize, analyze, model, and interpret the results that we get. If I don't understand what I'm working with, I'm probably not going to get the best possible results. Okay, so let's dig in. So data can be classified into 4 major types based on nature, properties, and characteristics. Knowing the type of data is important because it determines the appropriate statistical methods that we'll use when we analyze that data. So here we're going to discuss the different types of data that we'll be using, and we'll run through some examples using R. There are 4 classic classifications of data: nominal data, ordinal data, interval data, and ratio data. Okay, so this ends up creating like a hierarchy aspect. That nominal data, this is data where we can just tell the difference between 2 different levels in our data set. As basic as possible. It's mathematically simple, is that we know if 2 things are equal or not equal to each other. And so here we'll have something like red and blue, for example. We know that they are different from each other. We can tell the difference. Now, ordinal data, here we can tell which one is, we have an order to our data. So we could have like, dislike, or we could possibly have high, medium, and low. Maybe another one might be Monday, Tuesday, Wednesday, Thursday, depending on our analysis. So ordinal just says that we have an order to what's going on. Now, something about ordinal data, cyclic cycles are not going to be ordinal. So here's an example of that. Think about the color wheel. If I have a color wheel and I'm saying, red, orange, yellow, and so on, all the way up to purple, well, I could say that red is less than orange, less than yellow, and so on. That would make perfect sense. But when we come back around, purple would be less than red if I go all the way around a full color wheel circle. Ordinal data, there has to be just one order, and if something is less than another and that other one is less than another, we know we have inequality on those. And so if I'm talking about color along the color spectrum, the visible spectrum of light, then color is ordinal. But if I'm on a color wheel where it cycles back around, it's not. So that's something to be mindful of. This could also apply for things like quarters. When I'm talking about business quarters throughout the year, months, days of the week, if there's a cycle aspect to it, then it's not ordinal. Now, interval data, this is where we have if I have 2 values, I know what the distance between them are. And so here, the idea is I know I can measure how different or how close they are. Think about first place, second place, third place in running a race, competition, something like that. Interval data is where would be something like the time it took to get across the finish line. Ordinal data would be first place, second place, third place. So if I'm talking about first place and second place, it might be that it was real tight between those 2 athletes, or it may have been a blowout. We don't know. When we talk about ordinal data, we don't know if it was close or if it was far. If I don't know the difference, if there's multiple possibilities to land on that order, then it's ordinal data. Interval data would be something like the time between athletes as they cross the finish line, because there I know, hey, how much of a gap there was. If I know the amount of gap between the observations, then it's interval data. Now, there's a weird twist on this one for this next bit. Think about Celsius and Fahrenheit temperatures. All right, so temperatures on Celsius and Fahrenheit are interval data. Why is that? Well, think about zero. When I say 0 degrees Celsius and 0 degrees Fahrenheit, those are two different values. Like they don't correspond to the same amount of temperature. When I actually would be, if you told me this is 0 degrees Celsius and 0 degrees Fahrenheit, and I put my hand on each of them, there's going to be a difference in them. All right. So the next type of data, ratio data, has a true zero. So think about height now. Height, if I say you are 0 height in inches or 0 height in centimeters or 0 height in meters, doesn't matter the unit, it means the same thing. When I say 0, it does not matter what the nuanced scale is that I'm dealing with. It's going to be 0 every single time. The actual thing that we are measuring is going to be the same every single time if it is a 0 value. And that's called a true zero. And so ratio data is interval data with a true zero. Honestly, there aren't a lot of times that we have interval data that's not ratio. Most of the time, we just treat them as the same and just move on with it. I cannot think of a time in my professional career that made a difference for me, but there is a technical difference on these. So nominal data, mathematically, I can tell the difference between two levels. Ordinal, I know which is greater than the other. There's an order to the data. Interval data, I know the difference between observations. In a sense, we have a meaningful subtraction. And ratio data is where we have a true zero. So if I see the value of 0, it's 0 regardless of the scale of measurement. Okay. Ratio data is actually the level of data we need to be able to have a system of mathematics with division. And so that's an interesting aspect. For statistics, honestly, it doesn't matter, but it's a nice piece of trivia to know. All right, so let's go ahead and look at some examples of the types of data. So we'll look at nominal data. And so this is categorical data that cannot be ordered or ranked. It consists of labels or names used to identify different categories. All right, so let's go ahead and look at some examples. So here we've got gender, race, color, and religion. Now, here you'll notice that nothing is really on a spectrum. These are hard, discrete classifications. And so that's something to be mindful when we tackle our data. If there's a spectrum of values, it might not be nominal. So here's just an example of some code. So when we code nominal data in R, typically we'll be doing that with a character string or a factor. Factors are what I want to use when I don't want alphabetical order on what's on the presentation of it. So for example, if I wanted red, orange, yellow, and so on, Roy G. Biv of the order of the colors, even though it was on a color wheel, I would use a factor, and it would be an unordered factor. And here's an example with male and female. Now, ordinal data, here we have orders, an actual order to our categorical data. And there's a natural order or sequence to the levels in my data sets. So examples of ordinal data are educational data level, like high school, some college, and so on, socioeconomic status, and degree of satisfaction. Now, when I'm dealing with ordinal data in R, we're probably going to be using a factor. Nominal, we had character string was a possibility depending on what I'm working with. When I'm dealing with ordinal data, I'm probably going to be using factors to make sure that I have things in the right order. Now, the default ordering, when I use a factor function, the default ordering is to go alphabetically. So here, in this command, you notice I did not specify the order of the levels. By default, R is going to look at the alphabetical order, so female will come before male when we are doing our plots and we're doing other operations, even though it's not technically an ordered item of data. It will be in alphabetical order when I do my plots and my presentation and other coding things. Now here, we're specifying that's an ordered factor. And so this is similar to the factor command I did before. The default for a factor is an unordered factor. Not all functions in R will handle an ordered factor, but most will. And if I want non-alphabetical order for my data, I have to specify it with the levels parameter. And so here we're saying high school, college, then graduates as our order. And you'll notice that these are not in alphabetical order. If the levels were naturally in alphabetical order, I could shortcut my work by just leaving it blank and letting R just assign it alphabetically. Now the next type of data is interval data. Interval data is numerical data, and it consists of distances between the values on the scale. It does not have a true 0 point. A true 0 point is where if I change the scale, like I didn't change the actual value of the measurement, but I changed how we scale it, 0 would stay 0 no matter what. Best example of that is like feet, weight, almost everything we measure. The best counterexample of something that does not have a true 0 is going to be temperature in terms of Celsius and Fahrenheit. So examples of interval data are temperature, time, and IQ scores. Now, I'm running through an example that I found online. IQ scores, I'm not 100% sure if that's truly interval, because what does it mean to be 5 IQ scores higher? But we'll go ahead and run with it just because it makes sense to say, hey, this person has a higher IQ by 10 or something like that. So here we can do subtraction, and it makes sense to do subtraction, but the interpretation may be a little bit hard to wade through. So here, temperature is interval data. Now the next one is ratio data. And this is usually what we work with most of the time when we deal with numbers. This is numerical data that has a constant distance between the values on the scale and the true 0 point. So changing my units of the measurement does not change where 0 is located on the number line. It means I have ratio data. And so here we could have like income. So income, if I have someone's income in dollars, or in yen or pesos or something like that, $0 is the same as 0 pesos, same as 0 yen. So money is ratio data. So in conclusion, we've got 4 types of data to classify our data into, and those are nominal, ordinal, interval, and ratio. All ordinal data is also nominal. All interval data is also ordinal and nominal. All ratio data is also interval and ordinal and nominal. There's a taxonomy here, or an ordinal aspect, I should say. There's an order to these in that aspect. And understanding the types of data are important for selecting the appropriate statistical methods when we run our analysis and make our predictions. All right, so for your homework assignments, what I want you to do, I want you to go take the data set that you've already selected for your assignments, and I want you to go through and just classify each of the columns with these 4 classifications. So give me a brief introduction to your data set and the variables that you're working with. Give me summary statistics, such as mean, median, mode, range, and standard deviation as appropriate. Here's the one that's most important for the assignment: classification of each variable based on its type, nominal, ordinal, interval, or ratio. And give me a brief explanation as to why you chose these. Visualize each variable using an appropriate plot or chart, histogram, bar plot, or scatter plot. And give me a conclusion of what you find out what's going on. Now, please use R Markdown and produce an HTML file and post that to Canvas. And here are the submission guidelines and the grading. All right, I'm going to scroll up to the beginning just to make sure that we can see the punchline as we close out. All right, so that's all I've got for you. Life is short, do math.